Okay, so we're going to try to summarize some of the stuff that we've dealt with so far in that lab and some stuff we've referenced. Number one, we have seen the word potential difference used before. Now, a couple of things that we're talking about on potential difference, that we normally have a variable, we use a V, and we call this volts. Now, the whole idea and the concept here is the fact that this is the push or the force that drives the flow of electrons. Okay, so that's what pushes your current. Pushes your current. Okay, now our next thing is power. Now, our power is referred to as okay, so now power, we normally use a capital P to represent power. A couple of other things that we deal with when we talk about this. Our units is, we use a symbol W and it's watts. Now, a couple of things is a little different here. Power is normally directly related to our energy divided by time. So we have some form of energy divided by time. Now, a lot of times we'll refer to that energy as potential energy due to electricity, or PE, as we've done before, and it's directly related to voltage up above. But we can also say that power is directly related to the current in the circuit times the voltage of the circuit. Okay? So there's two different things that we can look at there. Now, our next topic here that we're going to deal with is charge, and we use a Q. Now, we can use a capital Q or a lowercase q. I'm going to put a capital Q there. Now, it's C and it is coulombs. Okay. Now, a couple of ideas here is our charge. Our charge is directly related to the number of electrons. And the charge of one single electron is 1.6 times 10 to the negative 19th coulombs. Sorry for the way that looks. Okay? Now, we're going to add a couple more things here to this. All right, our next topic we're going to talk about is energy. Now, our energy is normally related to, we're going to use an E. Now, sometimes we use a different symbol for it, but the units are in joules. We know that. That's J. No big deal here. We talk about the potential energy a lot here on this one, but we're going to have a lot of the equations that we can use that will help us. So another thing is time. We know that this is T, and we're going to deal with seconds. Okay? So not too big a deal. So when we look at this, we know several of these. Okay, so when we look at this one here, we're going to talk about current. Now, current, our symbol that we use for it is capital I. We have a unit, it's amps. Now, some of our equations for current, we normally have a couple of things we're going to talk about. The first thing is current is directly related to the amount of charge that passes a given point in X number of seconds. So how much charge is flowing at a given number of seconds. Now, sometimes we also say that the current is directly related to the amount of push and the amount of resistance that we see in a circuit. And that's what you try to look at a little bit in the previous lab. Okay? Now, resistance, we normally use a capital R for it. Its unit is this symbol here, which represents the word ohms. And once again, we're going to just relate that to the resistance is equal to the voltage divided by the current. The whole topic here is it impedes the flow of current. So that's the big topic that we're talking about there.